Hello, thank you for watching this video. So on this video we'll be doing question 6 of November 2020 question paper mathematics paper 1, and this is the financial mathematics. So I'm going to read the statement and then proceed to answer the questions that follow. So question 6, 6.1. On 31 January 2020, Tsepo made the first of his monthly deposits of 1,000 into a savings account. He continues to make monthly deposits of 1,000 at the end of each month until 31 January 2032. The interest rate was fixed at 7.5% per annum, compounded monthly. I'm going to read the statement again, 6.1. On 31 January 2020, Tsepo made his first monthly deposit of 1,000 into a savings account. He continues to make monthly deposits of 1,000 at the end of each month until 31 January 2032. The interest rate was fixed at 7.5% per annum, compounded monthly. Okay, let's go to 6.1.1. What will the investment be worth immediately after the last deposit? So they're asking the value of the investment immediately after the last deposit. So what they want here is the future value of this investment. They want to know what will this value be worth. So there are two future value formulas that you can use that are very similar. I'll write both of them. So the first one, so 6.1.1, future value is equal to x to 1 plus I raised n minus 1 over I. This is the first one, right? The second one, second future value formula, is FV, future value is equal to x times 1 plus I, right? Then 1 plus I raised n minus 1 all over I. So this is more or less the same formula, right? But the only difference is this, which is not there. So you use the first one on your investments when the first deposit is made at the end of your investment period. So in this case, the deposits are made monthly. So you will use this one if your monthly deposits are made at the end of the month. And then this one, so this second one here, you use it. So the second formula, you use it when the first deposit is made at the beginning of the first investment period. So the investment period in similar case would be in a month, right? But here, so that would mean that your first payment would have to be made at the beginning of the month. But in our problem that we have here, the first payment is made at the end of the month. That means this one we're going to use, not this one here. So we use this formula here when the first payment into the investment is made at the end of the first investment period. So which means in our case, which is the end of the month, and here this one is, we use this one when the first payment is made at the beginning of the first investment period, and so on. So I hope that is clear. So this is the one that we're going to use, because the first payment is made on 31 of January 2020, which means now it's at the end of the first investment period. So it's this one we're going to use. Okay. So let's clean this one, and we're left with this one here. So because I'm doing financial maths for the first time on my videos, I'm going to take it as if you guys don't know it. So I'll try to be basic as far as I can. Hopefully that will help. So now, what is X? So your X are your fixed payments into the accounts that are made over equal intervals. So now the fixed payments that the person is making into the accounts are those 1,000 that is depositing monthly. So you're depositing 1,000 monthly. So your X here is your monthly deposits into the account over fixed intervals. So the intervals in this case is your monthly. So your X here, let me write them on the side here. So your X is 1,000 a month. That's what your X is, right? Next one is I. So what is I? So your I is your interest rate. So you are told here that your interest rate is 7.5% per annum, right? So which means over a year, the person on the investment will gain 7.5% over a year, right? Which means now that 7.5%, if it will be gained over a year, it will be distributed over 12 months. So since this is compounded monthly, which means you are gaining interest monthly, that means that your interest rate should be split, that 7.5% should be split over those months so that you can get a division or an equal division of that 7.5% for 12 months. So what that means is your interest should be 7.5% over 12. So you are dividing it by 12 so that you can get how much is this person accruing each month of the year, right? So this interest rate here, what you have here is what this person will be getting each month for the rest of the year. That's how much interest this person will be gaining. So as you know, 7.5% is 7.5 divided by 100 divided by 12. So you can punch this on a calculator. You should be careful when you're punching this, because this is what a percentage is. That's the definition of a percentage. It's whatever this is divided by 100. That's the definition of a percentage. So when you punch this on a calculator, it should be 7.5 over 100 divide by 12. So this is exactly this. So if you punch on a calculator, let me find my calculator. So if you punch it on a calculator, you have 7.5 over 100 divided by 12. So what you have is what you have is 1 over 160. This is your I, which is that part there. This is your I. And then N. What is N? So N is the number of payments that are made into the account. That's what N is. How many payments were made into the account? You must find that out. So you were told that the first payment was made in the end of January 2020, right? So end January 2020. This is when your first payment was made into the account. So at the end of December 2020, 12 payments will be made, because it will end of January up until the end of December 2020. So in 2020, there will be a total of 12 payments made that year, because this person is making payments monthly. So, but this continued up until 31 January 2032. So these payments were made up until January 2032, right? So which means the person in year 2020, he made 12 payments. 21, 12 payments. 22, 12 payments. 23, 12 payments. 24, 12 payments, all those years, including the year 2031. By the end of 2031, by that year, 2031, he also made 12 payments into the account. So this person made 12 payments from 2020 to 2031. How many years are those? 2020 plus 2031. So this is from end December to end 2031. That's 12 years. Sorry, that's 11 years, right? Plus that year. I'm not sure if that makes sense. So from end January to the end of 2031, that is 12 years. So in between end December and end December 2020 and end 2031, that's 11 years. Plus that year, that's 12 years, right? So this person made 12 payments, right, for a period of 12 years. He made 12 payments. Oh, sorry. This person made 12 payments for a period of, boy. So this person of ours made 12 payments each year for a period of 12 years. So from this year here, early 2020, end January 2020 to end December 2031. This is 12 years, and he made 12 payments each of those years, which means from here to there, a total of 12 years times 12 payments was made, right? So from early January from end January up until the end of 2031, this number of payments was made into the account. But this is not where they ended to make the payments. They ended making the payments at the end of January 2032. That means now, from end January 2020 to end December 2031, they made 144 payments. Then plus that one payment that they made at the end of January, which means now our number of payments that were made into the account should be 144, which is for that 12 years from end January to 2032 plus that 1 month. So a total of 12 times 12 payments for those years plus that 1 month was made into the account, which is, this is 144 plus 1 month. So a total of 145 payments was made into that account. That's what your N is, and you know what your I is, right? So what they were asking you, they want you the value of the investment. So you have your monthly payments into the account, you have your interest rate, which is this, you have your number of payments made into account, which is your interest rate, which means you can just substitute things as they are. Then you'll get the future value of this investment after 145 payments, which means now that will be the value at the end of June 2032. So let's do that. So I'm cleaning this. I don't think I should have cleaned this I here. So we want the future value of the investment. Future value is equal to the X. Our X is 1,000. 1 plus our interest rate, that's 1 over 160. Raise 145 minus 1 all over 1 over 160. This is where we are. Then we can punch this on our calculator and see what our future value will be. So it will be 1,000 into 1 plus 1 over 160 all raised by 145, which is the number of payments made into the account, minus 1, all divided by 1 over 160. Which is the value of the investment after this number of payments is going to be FV is equal to 234,888 rands 53 cents. This is what the value of the investment will be at that time. So let's go to the next question. So if he makes no payments but leaves the money in the account, how much will the account be? How much money will be in the account on 31 January 2033? Let me repeat the question. So, if he makes no further payments but leaves the money in the account, how much money will be in the account on 31 January 2033? So this person, this is the value of the investment, right? When? On 31 January 2032. This is what the investment is. It's just this money here. So now they're saying, let's suppose that he does not make any further payments after this date, after this period, which is at the end of January 2032. So they're asking, if he lets that money stays in that account, how much value will it be in the end of January 2033, which is now a year later, which is after 12 months later? What will the value of this money be if it is left to stay for an extra 12 months into the savings account? That's what they're asking you. What will be the value of this amount if it continues to stay on that account undisturbed, which is now you're not taking anything out, you're not putting anything in, but at the same rates. So what you do is say, okay, 6.1.2. So you say, okay, my accumulated amount, because this will just accumulate in that period. My accumulating amount is equal to principal plus 1 plus interest rate raised n. So your n here, this n, which is the period on which the money remained into the account. So it remained for 12 months, because from end January to end January the following year, that's 12 months. So now our accumulating amount is equal to 234,888.53 into 1 plus I, which is 1 over 160 raised 12. And that's equal to, punch this on a calculator. I want to punch this on mine. What do we get? So it's this amount of hours, 1 plus 1 over 160 raised 12. So it's 253,123.54. This will be the value of our money if we leave it to accrue interest for the next 12 months into that account. I'm happy with this. I hope it's clear. Then we continue. 6.2. I'm going to clean the board now. Then to 6.2. Okay. 6.2. So they are saying Jim bought a new car for 250,000. The value of the car depreciated at 22% per annum according to the reducing balance method. After how many years will its book value be 92,537 rand 64 cents? Let me read this again. They are saying Jim bought a new car for 250,000. The value of the car depreciated at a rate of 22% per annum annually according to the reducing balance method. After how many years will its book value be? 92,537 rand 64 cents. Okay, so this guy here, he bought this car and he depreciated at the rate that we're given here, according to the reducing balance method. So there are two ways in which this thing can depreciate. It can be the reducing balance method and straight line basis, right? So the reducing balance method, reducing balance method, has this formula here. A is equal to P into 1 minus I raised n, right? And then we have the straight line basis. Straight line basis is equal to A is equal to P into 1 minus IN. This is the straight line basis. So you are told that this guy's car, Jim's car, is depreciating at a straight line basis, at a reducing balance method, which is depreciating in this method, which means now we're going to use this method to calculate how long will it take for it to depreciate to this 92,000 that we have here. So we have its new price and we have its current price. We want to know how long did it take to reduce from its new price to its current price. That's what they're asking us. So we're going to use this formula here. I'm going to remove this. Okay, so we have that A, our A is the current value of our car, which is, what is it now? It's 92,537 rand 64 cents. It's equal to P, which is the new price of the car. What was it? It's 250,000. 250,000. 1 minus I. What is our I? Is 22% per annum annually. So it's 0. So 22%, that's 22% of 100 annually. Raise n. So we're looking for this. So what do? We want n here. We want to solve this n. So what we do first is to divide by this both sides. This 250,000. 250,000. Here is it. You divide with 250,000 this side as well. So this one is gone. This one is gone. So we're left with what is inside here. So what is inside here? Punch it in a calculator. You'll quickly discover that this is 0.78 raised n, right? And then you can punch this in a calculator as well. So let's punch it. 92,537.64 divided by 250,000. So you'll discover that this is 0.37. You have this. You have this. So, you know, when you're doing exponents, it would have been nice if these bases were the same here. Because you just like, okay, this for this to be identical to this, which means now they should have the same power, right? But these two are different. So when you're dealing with exponential-like equations that don't have the same basis, you use the log function to solve whatever that you want. You introduce the log function. So now what you want, you would like this n to come down so that at the end you say n is equal to something. That's what you would like to do. That's what you would like to achieve. But it's up there now, so it's difficult to move it down when your bases are not the same. So to do this, you introduce a log function, right? You use log to remove that from the top. So what you do, you say, okay, I want this to come down and stop being at the top there. So to do this, you say, okay, I'm going to put a log of this. Then you say the log of the right, 0.37, right, is equal to the log of the left, which is log 0.78, right? So this, you put it here in front because you use the log to remove it from the top. That's what the log is for. The log is used to remove this end from the top to be in the front. Then once you have it in the front, you can divide by log 0.78, divide by log 0.78, then this and this are gone. So this side you're left with n is equal to, punch this in your calculator and see how many years you get. So you say, okay, my log of 0.37 divided by log of 0.78. You'll find that your n is equal to 4 years. N is equal to 4 years. So the tricky part starts here. When you have to remove that n from the top, you put this on the log and you put that one on the log. Once you put them on the log, then you can put your n in front there to multiply your right hand side. Then from there you just solve for n by dividing by log both sides. Punch in the calculator, you'll find that n is equal to 4 years, which is straightforward. So let's continue. 6.3. So I'm reading 6.3 now. So Mpho is granted a loan under the following conditions. So Mpho is granted a loan under the following conditions. The interest rate is 11.3% per annum, compounded monthly, which means the entire year, the interest rate of that loan is 11.3% for the entire year. So which means now it's compounded monthly, which means now you will have to split it over 12 months, right, to see how much they are charging here monthly. The second condition, the period of the loan is 6 years, right? The third condition, the monthly repayments on the loan are 1,500. Okay? Her first repayment is made 1 month after the loan is granted. I'm going to read this again. So Mpho is granted a loan under the following conditions. The interest rate is 11% per annum compounded monthly, which means now he's going to accrue. The bank is going to charge it 11.3% a year over 12 months, right? The period of the loan is 6 years. The monthly repayments on the loan is 1,500. Her first payment is made 1 month after the loan was granted. This is what this thing is saying. So let's go to the questions. 6.3.1. Calculate the value of the loan, right? So they want you to find the value of the loan. What is the present value of the loan? You want the current value of the loan, the present value of the loan. So the present value of the loan is given by this formula. X1 minus 1 plus I raised negative n all over I. This is the present value of the loan. So this formula assumes that the first payment is made at the end of is made 1 month after the loan was granted, depending on the compoundings. If it's compounded quarterly, which is 1 quarter after 1 quarter, that's when the payments start. This is what this thing says, right? Okay, so now they're asking what is the value of the loan. Present value of the loan, this is what you want. X is the amount that you pay on the loan, monthly repayments on the loan, monthly, which is 1,500. Your I is your interest rate, and your N, which is the number of payments that have to be made over that period, right? So let's write this on the side. So your X is the monthly repayment of what? What is it? It's 1,500, right? And your I is your interest rate, which is your I, is equal to what? It's equal to 11.3% over 12, which means now you are going to get, over a period of 12 months, you're going to get this part. This is compounded monthly, so you must know how much is being charged monthly, right? And I said the 11.3% means 11.3 over 100. This is what the top part means, all over 12. Then to punch it on a calculator, I'll say punch it as 11.33 over 100 divide by 12, because some people struggle to punch these kind of things on the calculator. So let's punch it and see how much our I is. So we have 11.3 divided by 100 divided by 12. So, this is bad. This doesn't look nice at all. Okay, so this doesn't look nice at all. So this is 113 over 12,000. This is what our I is. Doesn't look nice, but it is this. And then our N is the number of payments made. So this was made, the payments were made for 6 years. Each year it was 12 months. So which means your N was 12 months, 12 payments for 6 years, right? So, so the 12 times 6, this is your 72. So 72 payments were made. This is what this means. So we have almost everything there. So now what we want is our present value. To find our present value, say okay, present value is equal to 1,500. 1 minus 1 plus our I, which is 113 over 12,000. All raised N, which is minus what? Minus 72. All over 113 over 12,000. So our present value is equal to, say okay, punch that on a calculator as it is. So it's 1,500 times 1 minus 1 plus 113 over 12,000. All raised negative 72 over 113 over 12,000. So your present value, which is the amount of the loan that Mpho took out, is 78,173 rand 49 cents. This is what this means. This is the amount that Mpho took on loan. Mpho took this amount. So let's go to the next question. How much interest will Mpho pay over 5 years? So they want to know how much interest will Mpho pay over 5 years. Okay, so this is the amount that Mpho borrowed. So I'm just going to write it on the side there as well. So I'm going to say, okay, Mpho took this amount, 78,173 rand 49 cents. This is the amount that Mpho took. So they want to know how much interest will Mpho pay over the first 5 years. So they want to know how much interest will Mpo pay over the first 5 years of this loan, right? So we want to know how much interest Mpo will pay. To determine the interest that Mpo will pay, you need to find out how much. You need to find out how much Mpo paid over 5 years, right? The total money that Mpo paid over 5 years. And then that money, you subtract the amount that he paid off from the loan. So Mpo, calculate how much money did Mpo pay into the loan or on that 5 years, right? Then once you know how much he paid on that 5 years, you subtract that money he paid by the actual amount of money he paid to reduce his loan from the bank, to pay off his loan. How much? So you have that Mpo paid this amount, this much to the bank over 5 years. That's the first part. Now what you want to find is that how much money of this 78,000 did Mpo pay off. Once you know how much he paid off over that 5-year period, then you can subtract that from the total payments he made into the account, because then you will be left with the interest, because which means once you remove the money that Mpo have paid from, once you subtract the money that Mpo have paid into to reduce this amount, right, then you'll be left with the interest. So let's do this and see if you understand. So we're doing 6.3.2. I'm going to clean. So now, how much money have Mpo paid into this account over this 5-year period? So Mpo, amount paid into account, which means how much money did Mpo pay into this loan account, right? So the amount that Mpo paid will be equal to 1,500, right? Because he was paying 1,500 per month, times the number of payments that Mpo made over 5 years. So each year he was making 12 payments, right, for 5 years. That means Mpo made a total of 60 payments into this account at the end of 5 years, right? So Mpo, at year number 5, at the end of year number 5, he made a total of 60 payments. So he made 60 of these 1,500. So he made 60 of these guys. That means how much did he pay into the account? Then I'm going to calculate that. So into the account, he paid 1,500 times 60. That is 90,000 rands. So Mpo paid 90,000 rands into the account, right? Okay. So we know that this is the amount of money that he paid into the account. He paid 90,000. On this 90,000 that he paid, how much did he reduce that money by? How much of the actual loan is remaining? Once you know that, you can subtract the remaining amount of the loan from what? Okay, you can subtract the amount of the loan that he paid off from the total payments that he made. So I'll make an example. So Mpo here have paid 90,000, right? Then let's say Mpo, on this loan of ours at year number 5, he have paid 50,000, right? Then that would mean the difference of this and the 50,000 that Mpo have paid off that loan is our interest. So now what we need to find is how much of, because what we want to find, how much of this is interest. To find how much of this is interest, you want to find how much how much Mpo have paid from the actual loan itself, from the initial amount that he was loaned by the bank. So how do we do this? So we say, okay, at year number 5, what is the balance of the loan? That's what you need. You need to know what is the balance of the loan. So to say find the balance of the loan, you say, okay, the present value of the loan, is equal to X, which is our 1,500, 1 minus 1 plus I, our I is 113 over 12,000, all raised n. So what is your n there? N is a remaining duration of the loan. Because when you wanted at the beginning, when we were asked how much was Mpo loaned by the bank, our n was the entire duration of the loan, which was 72 payments or 72 months. Here, to find, so we're here number 5, we are left 12 payments to go. So we want to find what is the value of the loan, what is the balance of the loan at that point. So this is the balance of the loan. This is the present value, which is the balance of the loan. So 12 months all over I, which is 113 over 12,000. So your balance of the loan, which is the present value of the loan, is equal to, punch this in a calculator, you'll find what the balance on the loan is. That will be 1,500, 1 minus 1 plus 113 over 12,000. All these negative 12 over 113 over 12,000. So the balance of the loan at the year number 5 is 16,945 rands 1 cent. This is the amount. This is the balance of the loan at the end of year number 5. Okay, so if this is the balance of the loan, how much of the initial amount have been paid off? So you want to know how much of that given amount have been paid off, right? So to find that, you say, okay, that initial amount, that borrowed amount, right, subtract this, then you will know how much have been paid out. So the paid out amount, which is I don't know how to name these things. Loan, let me say, loan value paid off. How much of the loan, initial loan, have been paid off? Which is, it will be 78,173.49 minus 16,945.01, which is equal to 78,173.49 minus that. This will be 61,228 rands 48 cents. So this is what you have here, is the actual amount of loan that have been paid off at the end of year number 5. So from the initial value of the loan, which was 78,173.49 cents, this here is how much the initial amount have been reduced by, right? Which is over 5 years. On your loan of that, you have reduced it with this amount here. So now if you have paid 90,000 into the account, on your loan account, and this is the initial amount, and this is the value of your initial loan you have paid off. The rest of the money there is interest. That's what that means. Let me repeat this again. If on the account you have paid 90,000, right, and your loan of 78,000 is reduced by 61,228 rand 48 cents at the end of year number 5, that means that if you subtract this 90,000, if you subtract from the 90,000 you paid the actual value of the loan that had been paid off, you'll be left with the interest. So your interest will be equal to your 90,000 minus 61,228.48 cents. That means that your interest is equal to, or we punch it, 90,000 minus that thing, which is equal to 28,771 rand 52 cents. So this is the interest of the loan. This is the interest of the loan. So what the most important thing, you must find how much money has been paid into the account, and find how much of the loan have been paid off at that point. Then you find the difference, then you'll be fine. This is how you do this. I'm happy. Thank you for watching. Hope you find this helpful. Cheers.